Now I'm going to take you through the new packaged 5400L Aqualoop system, size for 1,427 gallons per day. Let's take a trip through the system. Here we have where water comes in, gray water from laundry and showers, comes into our process. This tank is our bioreactor. It's 5,000 liters, which happens to be 1,325 gallons in capacity. So the gray water comes down, goes into our tank. Looking inside our nice cutaway model here, we have gray water coming in through our Pure Rain pre-filter. There's a filter screen cutaway. Water comes in there. This gets cleaned up periodically by an automatic cleaning shower, and then the water goes into the tank. At that point, we have aeration and biological degradation of cleaning the water. Here we have a diffuser tube to get air into the process. We also have air coming into our membranes to aerate the water and to clean the water. After a period of time, there's our membrane station with our membrane cartridges. There are 6 of these cartridges in the 5400L. And water is then filtered through that with a transfer pump, where it transfers up through the backwash tank, outside the tank, and over to our holding tank. So the water comes up here, transfers over to the holding tank. Now I'll show you very briefly. We already have a detailed description of our automatic membrane cleaning, which on a periodic basis automatically cleans the membranes to reduce maintenance time. This is all controlled by the Inteva Connect program that allows backnet connection plus remote monitoring, remote programming updates by Inteva and by our local reps. Here you can see the schematic diagram, and now I'll show you the process flow. Hopefully, push the right button, it would work. So you can see all the important parameters and make adjustments as necessary, and then programming updates come from that. So there you have it. That's the basic process. We also, on a periodic basis, will remove sludge. There's a sludge pump. You can see it down there. Pumps out any buildup that happens, and you can get a good look inside the tank.
Steel scaffolding is first constructed on a concrete foundation, with gaskets placed between panels. Bottom panels are then assembled with bolts and nuts on the steel foundation, with side panels attached, leaving one section open, and lower panels and all upper side panels joined with bolts and nuts, and ceiling panels attached, reinforcing the whole structure.
Experience the Weil difference with a package system from Weil Pump Company. Weil's heavy-duty package systems are fully customizable and use the high-quality components you've come to expect from Weil Pump Company. And because all components are manufactured in the United States, package systems can be built to order in as little as 2 weeks. Weil's package systems begin with a reinforced fiberglass basin. Each basin comes standard with a reinforcement band that increases structural integrity by nearly 200%. Installation of the basin is made simple thanks to the lifting handles and threaded inlet and outlet openings. In addition, the basin floor comes pre-studded for mounting a Weil quick removal subbase. The subbase, available in simplex and duplex configurations, ensures that the quick removal systems are mounted securely to the basin floor and are properly spaced to mate with Weil's valve assemblies and basin covers. Weil's quick removal systems allow for the installation and removal of the pumps without the need to enter the basin. To install the pumps, simply slide them down the guide rails and they will automatically mount to the quick removal elbows at the bottom of the basin. Likewise, removing the pumps for maintenance or service is as simple as lifting them out of the pit. Weil's quick removal systems are available for 2-inch, 3-inch, 4-inch, and 6-inch pumps. The below cover bracket for the quick removal system guide pipes is available with an optional level control lifting assembly. This assembly simplifies the installation and service of the level control switches by putting the level control mounting pipe within easy reach from above the basin cover. The package system may also include a duplex valve assembly, consisting of 2 check valves and an isolation valve. Weil's valve assembly is spaced to be compatible with a duplex set of 2-inch, 3-inch, or 4-inch quick removal mounted pumps. The valve assembly can be mounted above or below the basin cover. The basin cover is available in checkered aluminum or painted or galvanized steel. The cover is designed to be fully compatible with Weil's quick removal mounted pumps. Finally, Weil's package systems are available with a wide variety of level controls and accessories, including tethered float switches, oil sensing switches, transducers, and simplex, duplex, triplex, or quadruplex control panels. Contact your local Weil Pump Company sales agent for information, pricing, and availability on the package system that meets your requirements, and you'll see why Weil Pump Company is simply the best.
All good. This pump is finished.
McCarthy again with Weil Aquatronics, and now we are standing at the domestic water booster system. This one is for the north tower, correct? You have another one that's identical to this for the south tower. So we'll start off real quick with just the basics and start from the beginning and go through what the components are. You're probably familiar with this kind of system already, so I'm not gonna be telling you anything you probably don't already know. So anyway, so we start off with the suction. This is the suction coming in from the city, going into the blue piping, which is our suction manifold. Come through the blue piping to a little valve over here, a 90 and a little valve on the end of this pipe, end of the manifold, and that goes to this plastic line. This goes up to the suction pressure gauge, and inside the panel is a suction pressure transducer. Same thing, as we come through each pump, we've got an isolation valve for the suction of each pump, just a butterfly valve. We go into the pump head here, what liquid in, electric motor. We come out, we go into a check valve on each pump, up to another isolation valve for each pump, same butterfly valve, and then into a common discharge manifold, same pressure line coming off of here, going up to the discharge or system pressure gauge and transducer. And then this one also has a little valve right here, and it goes down and over to the tank off the discharge side. So that's the basic components. Then of course a stand for the control panel, brains of the whole thing. HMI, human machine interface. This is where you're going to look at what's going on. You actually have a low system alarm right now. We'll set that, we'll go over that in a second. And then this, you see this line going down here. What is that, a 3/4 inch line maybe? Copper line going over to the hydrodynamic tank. And all this really does is help you at times when there's no flow, no demand, helps the pump stay off longer. Tank acts similar to a pump, feeds small amounts of water to the building in the event that there's leaks or somebody flushing one toilet, turning one sink on. You don't necessarily need the pumps to come on. Tank will do that job. Also, they tend to stabilize the hunting with the VFDs running these things. They ramp up and down to maintain the pressure. Notice we said we had check valves on here, not pressure reducing valves. So we're controlling the pressure by variable frequency drives that are inside the control panel. So this can tend to help stabilize that a little bit. Any questions about the basic components?
How much pressure has to be in how do you regulate air pressure?
Air pressure in these tanks is equal to system pressure set point, which in this case is 93 psi, or actually what's better is equal to start pressure, which is 5 pounds less than that. The SynchroFlow likes to have the tanks go pretty much completely empty every time they get used. So if you set it at actual discharge pressure, the water gets completely out of the tank, theoretically anyway, before the pump starts. It works the same if you set it at start pressure of the pumps too, but it gives it a little more time to react, and there's not a delay. If you have high suction pressure, which you have very high suction pressure here, then you're fine to have equal to 5 pounds less. Then set point is a good air charge for the tank. Now, you can only tell what the air charge is in that tank when that tank is empty of water. So this is one routine thing that you're going to be doing maybe once a year. And the easy thing to do is if you got a key or anything, you can kind of walk by. The little cap is not on there. I'm not sure what happened to it, but it's just a regular Schrader valve like you'd see on a tire. Anyway, cap's already not on there, so if you have a key or something, stand to the side and just give a little push. Just like that. If air comes out, your bladder is generally in good condition. It's not 100% conclusive, but it's a good indicator that your bladder is in good shape. If water comes out of that, you have a problem. Your bladder is most likely ruptured. If nothing comes out of there, then for some reason you've lost your air completely, and now the inside of the bladder is just full of water. It's pushed it all the way up against this, and you're not getting any air out.